Assalamualaikum and hi to our lecturer, Madam Junaida binti Mat Said. We will present about the application of differentiation for our group project Calculus 1 MAT183. Our group member consists of 4 members, namely Masturina Balqis, Ainul Alisha, Noor, Farisya, Azlin, and myself, Nurul Nabila. First, what is differentiation? Differentiation is a process of finding the rate at which a function changes with respect to one of its independent variables. The result of a differentiation is a new function called the derivative. It represents the rate of change of the original function. The derivative of a function fx is denoted as f prime of x or dy over dx. Dy represent the infinitesimal change in the function's value and dx represent the infinitesimal change in the independent variable. When do we apply differentiation? We apply differentiation when we want to determine the speed or distance of moving objects, increasing or decreasing of a function, and when we want to find the maximum and minimum values of a particular function. There are 5 applications of differentiation, which is related rates, analysis of function 1, increasing, decreasing, and concavity, analysis of function 2, first derivative test, second derivative test, and relative extrema, applied maximum and minimum problem, and the last one is Rolle's theorem and mean value theorems.
The introduction of our group, related rates. Related rates are rates of change associated with two or more related quantities that are changing over time. Related rates problem can involve various scenarios such as geometric figures, fluid flow, motion, or physical systems. The key idea is to use the chain rule of differentiation to express the rates of change in terms of each other.
Okay, so the problem statement is an airplane is flying west at 500 feet per second at an altitude of 4,000 feet and a searchlight on the ground lies directly under the path of the plane. If the light is kept on the plane, how fast is the searchlight revolving when the airline distance of the plane from the searchlight is 2,000 feet due cast? In the question, it had given x right. So, x means the distance of the plane from the searchlight, and the theta means an angle of elevation of the plane at the searchlight. So, from the question, it had given the information of dx over dt is 500. But we all know that the airplane will fly to the west. That means the airplane will go to the left of us. So, the 500 feet per second will gonna be negative 500. Then it said, how fast is the searchlight revolving when the airline distance of the plane from the searchlight is 2,000 feet due cast? That means the question wants us to find the angle of elevation of the plane if s equal to 2,000 feet. So the question had given dx over dt and want us to find d theta over dt when s equal to 2,000. So first of all, we need to find d theta over dt. But how to find it? So this is how you do it. Okay.
So, to solve this kind of problem, first thing first, we need to find the chain rule. The chain rule is related rates of each derivative. So, in this question, we need to find d theta over dt. So, the related rate is d theta over dx times dx over dt. But we need to find d theta over dx because the value of dx over dt has been given in the questions. The second step, we need to find theta in terms of x. So, how to find theta in terms of x? We need to use tangent theta equal to 4,000 over x. We implement the formula of tangent equal to opposite over adjacent. So, the opposite value is 4,000 feet that's located in the y-axis, while x value remains as x located in the x line. So, the value of theta we got is 4,000 x negative 1 times tangent negative 1. And then the next step we need to do is finding the derivative of d theta over the x. So the derivative of d theta over the x we got is negative 4000 divided by x squared secant square theta. So the next step is we need to substitute the derivative of d theta over dx and derivative of x over dt. So the value of negative 4000 over x squared times secant square theta we have been got it from the previous slides, and then the value of negative 500 we have got in the question itself. So the second last step is we need to find the value of secant square theta. So how we can find the value of secant square theta? We need to implement the formula of tangent theta. Tangent theta equal to opposite of adjacent. Opposite itself, the value is 4000 and the theta is 2000 because in the question it has been stated that the value of x is 2000. So we divide these two and we will get the value of tangent theta equal to 2. So we need to derive the formula of secant square theta. It will be 1 plus tangent square theta. So what we need to do, just implement the value of tangent theta into tangent theta formula. So it will be 1 plus tangent theta, that's equal to 2, and then we need to square it. So the answer we will got is 5. So the last steps of this problem solving is put all the value in the chain rule and calculate the final answer. So as stated, we need to find d theta over dt. So the value of d theta over dt is negative 4000 divided by x squared and times by secant square theta. And then the value itself will be times towards negative 500. So we also have find the value of secant square in the previous slide. So we just need to substitute the value of secant square theta in the formula. So we will get negative 4000 divided by 2000 square and times the value of 5, that is the value of secant square theta. And then all of the value, after calculated the value of negative 4000 divided by 2000 square and times 5, we will times the value with the negative 500. After doing the calculations with the calculator, we will got the final answer, that is d theta over dt equal to 1 over 10 radian per second. So that is the final answer for our problem statement.
The conclusion that we can actually get from this video is you should now be able to understand the idea of differentiation, able to work with any of related rates question, know how to apply the correct chain rule. To conclude everything, the application of differentiation is a fundamental tools for understanding and solving problems in mathematics, life science, economy, computer science, and engineering. So this is the link that we have been referring to through our project. That's all from us. Thank you. I hope you guys understand what related rate is.